So first speaker today, I'll leave you the floor without further ado, Professor Ekstrand from Idaho, from Boise State University. Thank you so much for welcoming him today in Brussels.
Thank you. Yes, I am an assistant professor in the Department of Computer Science at Boise State University, where I study a bunch of things around human-computer interaction, recommender systems, information retrieval, broadly looking at the issue of how do we make these algorithmic systems we're building good for the people that they impact and that they affect. And I do this work in collaboration with the People and Information Research team that I co-lead with my colleague, Dr. Soleil Pera. Some background, philosophical background of where a lot of the ideas, a lot of the ways I think about these things come from are grounded in Ursula Franklin's work on the ethics of technology, particularly her lectures and books, The Real World of Technology, where she makes a few key observations that have really influenced the way that I think about the kinds of systems we are trying to build. The first is that technology is not just artifacts. We think it's very easy for us to think about technology as it's the things we build. And one of Franklin's big points is that that misses the point. The key into what technology is doing and how it works is that it is the result of processes that involve people, and also that it induces changes in the kinds of processes, in the ways we do our work. And so that to really understand what's going on, we have to look at the relationship of the technological artifacts with human processes. With that, it affects people. We deploy recommender systems are intended to get people to change their behavior. We want them to buy more stuff, or we want them to watch more video, or maybe we want to help them have a more enriched reading experience. But if it wasn't intended to change what people do, we wouldn't run them. And then finally, the technologies that we work with, that we build, were designed by people making decisions. Our technological environment is not just this thing that is an artifact of nature that we have to take as is. There are some constraints, like the rate of gravity is a pretty strong constraint that we can't change. But a lot of other things, the way we respond to the kinds of technologies we build, are the result of decisions. We could have made other decisions. We can make other decisions going forward. And so thinking about the decisions that were made, why they were made, what decisions we should make going forward is very important in order to make sure that the technological systems we build of all kinds are actually going to promote human welfare. So with that, I think a lot about how that applies to recommender systems. And I'm sure most of you have at least experienced recommender systems, if not built some of your own. And we're talking about systems that are recommending things to people: books, movies, news articles to read, apps to install. Basically anything we're providing, hey, user, here are some things that you might want to engage with. The key questions I want to raise tonight are, who is involved in designing and evaluating our systems, and what is the impact of these systems? Now, with thinking about who else is involved and thinking about engaging more people, I am not suggesting that we go design our products by user voice mob rule. Just put up a user voice forum and do what everybody says you need to do. But that engaging with users in a principled fashion is one leg of that combines with expert design and data-driven analysis of how people interact with systems to inform the kinds of things that we build. So we're going to go deploy a recommender. We're going to put out a book recommender, or we're going to put a recommender into our news service. Who benefits from the recommendations? We often think about the recommender provider. We think about the user, but there's a lot of stakeholders in the recommendation process. There is the user themselves. There's the vendor that's operating it. There's the vendor's shareholders, if we're talking about a corporation or a commercial enterprise. There is the content creators, and depending on some domains, these are going to be conflated, but in books, you often have an author and a publisher and a vendor who are all distinct entities, and they all might get different things from the fact that books are being recommended. The publisher might care that their books are being promoted, but they don't care about any individual author so long as enough of their books are being promoted, whereas an author really may be able to benefit from the visibility of the recommendations. And the vendor wants to sell books. They may want to sell books with higher margin, independent of what the publisher wants. And then finally, there is the broader community, and that can go as big as the society as a whole, as far as the stake that they hold in the output of the recommendations. So one thing we need to think about is who all's voices are involved in the design process and how are they involved in the design process. I'm going to be circling back to this a little bit later, but who all, not necessarily, so we can explicitly engage users to get what they say, or we can look at their behavior. But in either case, we do need to think about what all users we're looking at. So you have a bunch of users and they're coming to your search engine, and they're typing in queries and they're going and finding results or not finding results, and you have a metric of query satisfaction. Maybe it's how quickly they're able to go and find a link and then they don't come back or until they have a different query. If you just measure that across all of your users, your statistics are going to be dominated by the largest user group. So you might be just meeting their needs, and the information needs of a different user group may be different. So you may be doing really well at meeting the information needs of 25 to 40-year-olds, but are you helping 70-year-olds find the information that they need about their health care, about their retirement plans? So a group at Microsoft Research undertook a study on Bing that tried to address this. They segmented the users by demographic group, and then they looked at search result satisfaction per demographic so that they could start to get at these kinds of questions. If we introduce a change, what all groups of users benefit from or are harmed by this change? So they can start to recognize that their users have different needs, and they can try to make sure that they're meeting the needs of all of the different kinds of users that come to their site. Another challenge when we're doing these things, or when we're building out these recommender systems, or any kind of user-facing data science system, is the limits of behavioral observation. I hope many of you are probably familiar with A/B testing, where you take you throw two different versions of a system at users, you see how they respond to the two different ones. You're looking at behavior like purchases or watching videos. Well, there's a little problem with this. Behavior is a noisy and funny signal. Neil Hunt observed in his keynote at the 2014 Recommender Systems Conference that the metrics they have cannot distinguish between a user finding interesting videos and having a more fulfilled life because they're watching interesting shows on Netflix and being addicted. They both look like watching videos. So you roll out a recommender and people watch more videos. Are they having a more fulfilled Netflix experience, or are they neglecting the upkeep of their house? Netflix has no way of knowing from the metrics that they measure. This is a significant challenge. We don't have a good way to address it. For most of the things I'm raising tonight, I have a lot more questions than answers right now. And I hope that many of you will work on trying to figure out what some of these answers might look like in the particular applications and settings that you're working in. But with this, we also have the intention behavior gap. So a couple thousand years ago, a guy named Paul said, what I want to do, I don't do, and what I don't want to do, I do. So the fact that a user is watching a certain type of video doesn't necessarily mean that's the type of video they want to watch. There's a couple of possibilities. One, they might not really understand what they watch. If they say, hey, I want to watch more documentaries, and they watch comedies, is it that they don't really want to watch documentaries as much as they think they do, or would they like to make a change in their watching behavior? If we can figure out which of those is true, we have an opportunity for the recommender to help, because recommenders are really, really good at working with behavior. We can look at the videos people have watched, and figure out which videos they're most likely to watch. If we can combine that with information on what kinds of things they say they want to watch, then maybe we could build a system that recommends the next step, something that's one step closer to their goal, but based on the behavioral data, we know that of the 20 things that would move them towards their goal, this is the one that they're most likely to actually do. Huge opportunity here for recommender systems. I have yet to see it explored. Some of us are kicking around the idea, but haven't seen it actually deployed very much yet. So yeah, find baby steps that get the user closer to their goals. And there's a psychological tool that can help with this called the ROSH scale, which lays out a bunch of tasks on a difficulty level. So if I'm trying to maybe improve how much bicycling I am doing, I can, on the very easy end of the scale, I can ride down the block, or I can ride down this nice green belt we have that runs by the river in Boise. Or at the very hard end, I can go do a 1,200 kilometer endurance event out in Colorado. And then there's a whole bunch of things in the middle there. And you model the user's current capability on this scale. And then maybe you can recommend things that move them ahead on it. So that's one particular tool. If you have the user's goal, where they want to go, you have the user's behavior, where they're at now, you can use that to point, maybe we could use that to point this ROSH scale in that direction and help the user get there. A lot of opportunity here. One of the other challenges with the way that we interact with our recommender systems and the way that the design process works is what Ursula Franklin calls reciprocity. And reciprocity is the give and take that is present in ordinary face-to-face human interactions. It's not just a one-way, and it's contrasted, basically the contrast is broadcast versus conversation. Now, a lot of times our systems are built so that, we come up with designs, we maybe test them with users, we maybe get a little bit of user feedback, but users are not involved in the process of designing many of our data science systems. We give them to them, we test them on them, we maybe solicit a little bit of their goals. Their participatory design provides a framework for doing this, but there's some significant challenges. How do we scale participatory design to web-based systems? Participatory design works great when you can get people in a room and talk with them about what they need from a workflow management system or a database for a business or something like that. But how do we scale it up to the web? And how do we do it with algorithms? Like if you're wanting to talk with people about, okay, we need to manage our point of sale, and you can talk with people, okay, here's how you're going to enter in design, or here's how you're going to enter in data, okay. Here's how we're going to be encoding, here's how we're going to structure the loss function for training a recommender algorithm. A lot of the stakeholders are going to have no frame of reference for understanding that conversation whatsoever. So one of the big challenges is how do we meaningfully engage them and give more stakeholders a meaningful voice in the process? And transparency so users know voices are being heard. Because companies do focus group studies, and they do various kinds of user studies. But users don't see any of that, or very often. And so it feels like decisions are just coming down. One example of this was when Twitter introduced their algorithmic filtering for the feed. And when they did that, there was an outcry from a number of you. There's many good reasons to do that. Twitter, there's a lot of data on Twitter. A recommender to help you filter to the stuff you actually care about could be pretty useful. But it fundamentally changes certain aspects of the interaction of the service. And many long-standing users were concerned that that was going to basically break the way they used it, and felt that they had no voice in the process and that their concerns were being completely ignored. So we have, giving users a voice may also help with some of the PR problems around that. You may get to the same decision, but if users know they're being engaged with and that their voice is mattering in the process of designing these systems, might it be better? I haven't seen a good example where that's happened yet to know, but it's something I think is worth trying. Another one of these challenges in how these recommender systems can be good for people is the kinds of things they promote. So Ev Williams, creator of Twitter, gave the analogy that if you have a car crash on the side of the road, a lot of people are going to look at it. The internet observes this behavior and decides that what people want are more car crashes. So it tries to provide them. When our metric for recommender success is click, then what we optimize for is content that people will click on. Who cares whether it's actually useful once they get there? So we need to think very, very carefully about how we define success, who's involved in the process of defining success, so that we reward the kinds of behaviors that are going to contribute to users having better experiences, societal well-being. You might have heard a little problem we've had over in the United States with fake news. The way that the news recommendation and advertising system works was a catalyst for some of the dynamics for which that spread. Another way things can go wrong is dealing with social biases. The data that we train recommenders on comes from people. People are biased and messed up. When the recommender is trained on that data, the recommender will quite possibly be biased and messed up. When does that happen? How much does it happen? What are those effects? I'm working with one of my students right now on a project around that, trying to look at what does book recommendation algorithms do with regards to the distribution of the genders of book authors. Do they recommend more books by men or women, and how does that relate to the distribution of books that users are reading that are being fed in as the input data? Another recent example of this was a blog post that came up, it was really circulating my Twitter feed a couple of weeks ago. They're testing out, I don't think this ever got to production, thankfully. They're testing out a recommender that was doing semantic analysis on restaurant reviews, and it was using Word2Vec. And it was doing this semantic analysis with Word2Vec to try to do a restaurant recommendation. And they noticed that the restaurant recommendation engine output was ranking Mexican restaurants surprisingly low. Well, turned out what happened was that the Word2Vec model, trained on a bunch of internet content, picked up an association between the word Mexican and the word illegal. And so it thought that since illegal is bad, Mexican must also be somewhat bad. That fed into the recommender, and it downgraded the recommendations of Mexican restaurants. Thankfully, they discovered this and caught this before ever putting the recommender into production, so far as I know. But it's one of those things that can come up if we're not careful about the data we're using, the algorithms we're using, the evaluation metrics. Word2Vec can do a lot of great things, but there's also some serious problems with the kinds of words associations it learns when we use those and feed those into additional settings. So what do we need to make all of this better? A lot of things. We need to figure out how to measure some of these social impacts and social effects. There's a lot that we don't know how to measure well. Very big open area of research. We need to, I think that it's very much worth investing in figuring out how to do participatory design for modern web systems and modern data science systems. How do we engage multiple stakeholders in the process of designing and evaluating the systems that we build? How can we use this intention behavior gap to build cool things? Can we build recommenders that are going to help people eat more healthy meals that they're likely to actually cook, rather than just recommending them a bunch of healthy things, they're like, that's too much work, I'm not going to do that tonight. And also another piece is how do we provide, what is meaningful control, and how do we provide that over the recommendation process so people feel like they're in control of their recommendations and the recommendations are helping them rather than the other way around. So, things to think about. What's the impact of your system? How do you measure it? What are you going to do about it? That link is supposed to work. Unfortunately, right now, due to a continuous integration failure, it is not working. As soon as that's fixed, that link is going to have, or that URL and QR code will have a list of all the references and other articles that I talked about, so you can go read more about them. But I'm happy to take any questions if we've got a few more minutes.
Yeah,
or
thank you.
Yeah.
Yeah, I was wondering, like the type of stuff you talk about, Netflix and book recommendations, that's pretty harmless stuff, but especially in the United States, the same types of algorithms and the same types of systems are already used in like credit score calculation and affect people's ability to get a loan or get a good credit score. How do you feel then about like the principle or the idea of algorithm auditing and system auditing to that types of systems?
So I think it's really important. In the United States, for some of those applications, we actually have it relatively easy because of the legal framework that we've adopted for dealing with discrimination. Disparate impact is fairly easy to machine encode, and also provides a black box way of looking at the algorithm. So you don't have to actually audit what the algorithm is doing. You can audit statistical properties of its output. So it's really important work, and there have been some very, very promising results in doing black box auditing of arbitrary algorithms for disparate impact. One recent one, or one in the last couple of years, by Suresh Venkata and some others, what's it called? Certifying and removing disparate impact, I think is the name of it. But yes, it's very important. But how to do it and how to do it meaningfully is difficult. I think that black box approaches are probably one of the more promising directions to go. For one thing, they let us audit any system, not just ones we have the source code to. And they let us look at, they deal cleanly with things like, okay, you could say, well, yeah, race is not a variable in the model, but we've got some correlates with race. Black box approaches, where we're auditing the statistical outputs of the statistical properties of the output of the system, let us deal with that because they don't care whether race is or is not a variable. They care whether it's correlated with the output.
Yeah. Yeah, I definitely agree because like some people might get the impression that, yeah, show us your algorithm or show us your system, but it's immensely complex. There's perhaps tens of teams or dozens of teams working on it. It's not like you can simply show it on a diagram, but you can definitely measure the output statistically. Yeah.
The black box also allows for adversarial audits. If you get appropriate access to the system that you can do sufficient input perturbation, then you can audit without the full cooperation of the system vendor.
Any other questions, remarks, suggestions?
Yeah, if we could relate it to ethics, if the designer or the developer, whatever the title is of this person or team, if they don't have the notion of, let's say, ethics, how can you build it in?
That is a really, really good question. So how do we build in the notion of ethics? That's one thing that I'm working on the educational aspects of my roles. I'm creating the Intro to Data Science class for our master's program starting this fall, and we're going to have ethics in it.
Second question. Can you use your system to influence within a certain time frame or forever time frame? Can you influence the thought process or behavior of people? Let's say that right now, if there is a shooting, let's say in the US, the reflex would be buy more guns. Could that be turned around, perhaps?
Quite possibly, but I have seen very, very little research on how to do that effectively. But yeah, they are, there's every reason to believe that, so the information people see has a significant impact on the way they understand what's going on in a situation, the way they view the world, et cetera. And recommender systems shape often the information set that people are exposed to. So yes, we can, I mean, yes, the recommender is going to influence people's opinions and behavior. How to do that in a principled fashion is an area of open research. Well, and it's an area of research that I think a lot of computer scientists are kind of loath to get into because it feels more opinionated than trying to be neutral. I'm of the persuasion that really there's no such thing as neutrality, but persuading, and this gets to the ethics piece as well, is we like to cling to the idea that our data and our data science is somehow neutral because we're drawing conclusions from the data. And they're very high profile data scientists who, that's the response to questions about bias in the system. It's like, well, we're just following the data. But we have to figure out, and this is a problem that I do not know how to solve at scale other than just continuing to talk about it every chance that we get, is no, we have to interrogate how did the data we have that we're following come to be? What were the biases? What were the problems when we collected with it? Asking a set of questions. The data is not, ground truth is only ever noisily observable. But a lot of times we don't like to think about that. Oh, I have this accuracy on this data set, therefore I did a good job. We have to get that thing, and I think it's as many people as possible beating the drum. I don't know of a better way to do it right now.
Take one last question. Two questions.
Is anyone discussing trade-offs? So I can see a situation in which algorithm A makes people watch more videos, algorithm B makes people watch educational videos that you would ideally get them closer to their goals. So, you know, people who deploy typically want the turnover. So how's this playing out? I'm new to the topic.
So one of the standard things in research on fairness and machine learning, especially when people are developing new algorithms that incorporate fairness constraints or fairness regularizers, one of the standard things that you evaluate with that is you look at the trade-off between your fairness constraint and your classical accuracy metrics. And so it is being done in that sense. I haven't seen it being done yet in a more high-level sense like you're talking about, but it is when we're modifying the algorithm to try to say, okay, we want it to recommend a more diverse collection of authors, for example. Well, what does that do to our accuracy is kind of the standard question. Oftentimes, it has surprisingly little effect. You can get very, very close to the same. In the preliminary results we have on the there's a lot of things you need to go fix in these results, but the preliminary results we have, we can just hard force the recommender to recommend an equal number of books by men and women, and our recommender accuracy metrics stay basically the same.
Last question.
So it seems to be underpinning what you're saying is ultimately who gets to set the success metrics and how those are set is where the ethical question really lies. And I guess in a similar vein, we could look at the medical establishment. The medical establishment doesn't necessarily go to the public to say who should we keep alive or not. They've taken an ethical stance. Well, our core ethic is we keep everybody alive as best we can. Does data science need a similar Hippocratic oath, a similar set of standards that aren't, and if so, whose ethics would they belong to?
That's a very, very good question, and that is one of the reasons why, at least at this stage, I'm advocating for going the participatory design route, is that we can have a broad conversation about what ethics should be incorporated in a system. Maybe we'll have different systems that embody the ethics of different groups or different ethical frameworks. We do find that there's pieces of Hippocratic Oath style things that show up in places that don't get a lot of press. The Association for Computing Machinery has a code of conduct. And one of the pieces of that is to consider the impact of your systems, and it basically has a do no harm in it. And it further goes on to say that harm does not need to be intentional, but it can be the unintended result of a system built in good faith. And it expresses that computer scientists have an ethical obligation to consider what those unintended consequences of their systems are. So we have some of that, but we don't build that into our educational and training processes very much. We don't have new computer science or data science graduates pledge to uphold the ACM code of conduct or things like that. Canada has, for all engineering graduates, or at least most engineering graduates, they have basically an oath that they take regarding making sure that the products they engineer are going to be good for people and they're going to take into account safety and those kinds of things. This is applying mostly to mechanical and civil and engineering and those kinds of classical engineering fields. There's been a little bit of work on trying to get that for computer science. Nothing has really taken off. I think there's a lot of promise in that. And it's going to vary based on the application. Like, there are some things that like building a racist predictive policing engine. I think hopefully we should all be able to agree that that would be a bad thing. In recommender systems, it gets fuzzier.
But that goes to the core of my second point. We all agree. We don't all agree as a society, right? That's why we go to the polls. If we all agree, we wouldn't need to do that, right? Everybody has their own personal ethics, and then as communities, you have different sets of ethics. Who's ends up dominating? That's a big question.
And that is a tough question that I don't have a good answer to right now. I would like to see a widespread code of ethics for computer scientists and for data scientists that say, yeah, we're going to pay attention to these kinds of things, and we're going to figure out how to assess whether the systems we're building are learning racial or gender biases and deal with that. I don't know the political process to get that done.
So thanks so much.